What examples of force did we find on this page? Kaylin. What? Yeah, what examples of force did we see on our change in motion page? Kicking the ball, that's going to be a push. Thank you, Griffin. Good. Cooper. Grabbing the ball would be a pull. Perfect. Now, when we look, everyone look at this second picture. It says a player's kick applies force. The ball's motion changes in direction and speed. So if the ball is coming towards you and you kick it, your goal is that the ball what? It goes somewhere else, right? If I have a ball and it's coming at me and I kick it, is its direction going to continue along the same path?
No.
If I have a ball and it comes towards me and I kick it, what's my goal? It's going to change, right? It's going to go somewhere else. The hope is that if I'm playing soccer and the ball's coming towards me, I don't want the ball behind me. I want to send it that way to someone else's goal, right? That's the really cool thing about force too, is you can change the position, change the motion of something using force as well. So it's rolling towards you. I'm going to apply the motion of push, and I'm going to change the direction that ball travels to somewhere else. Can you stop motion?
Yeah.
What are some ways you can stop motion? Joey?
Like you can grab it.
Yep, and we see at the bottom, catching the ball stops its motion. What else can we do to stop motion that we read about today? Charlie?
You could put your foot on it to stop it.
You could put your foot on it. Now, aside from soccer, what are some ways to stop motion? Emery?
On a bike, great.
Yep, on a bike, you're using the push force to go, right? When you're pedaling, you're pushing in order to get going. If you want to stop it, what type of force are you using? What is that, Griffin?
Cool.
It's going to be that pull, right? You're pulling it in, kind of pushing it in, I guess, kind of funky. And you're stopping it. You're going to stop its motion by applying those brakes. Ray?
Another way you could use, another way is to, like, if you're playing a softball game, you could, like, catch the ball and get somebody out, like, catching it.
Yeah. You could, right? Perfect. Guys, we are going to, let me think. We might stop there for now. You know, I will read these next pages to you. Sound good? You guys can close up your stuff and I will read these next pages to you. And we'll stop and have some discussions about it. Does that sound good? So a little writing break and we'll do them. So these ones we're going to be reading about. Our heading tells us we are going to be reading about
Types of forces.
We're going to learn about contact forces, friction, increasing friction, and reducing friction today. And we'll move on to the next ones tomorrow. Sound good? So contact forces. There are many types of forces. The forces you are probably most familiar to are contact forces. Contact forces happen between objects that touch. So contact forces happen when objects, which makes sense, right? You see that force happening because something is touching something else. Think about a baseball game. The pitcher must touch the ball in order to throw it. A bat must touch the ball in order for it to change its direction. A player's glove must touch the ball in order to catch it. So those are all contact forces. Whether you're stopping or changing the motion of it, you had to come in contact with it in order for that to happen. Next up, we have friction. Show me our example of friction we talked about earlier. We have very little friction. Show me. And then we have a lot more friction when you apply that force more. You have more of a push. Good. A block slides on the floor. It then slows down and stops. Why does the block slow down and stop? A contact force called is acting on the block. Friction is a force that occurs when one object rubs against another. If a block is sliding on the floor, what is the block rubbing against? The floor. Very good. And we're going to do a little experiment with different friction, I believe, later on too. Friction pushes against the moving object and causes them to slow down. Different surfaces produce different amounts of friction. Rough surfaces, such as sandpaper, produce a lot of friction. Can you imagine that? Sandpaper, it's all bumpy. Would it have more friction? Yep. Smooth surfaces, such as ice, usually produce little friction. Makes sense, right? How many of you have ever had the chance to be on ice? And is it pretty easy to like slip and slide on it?
Yes.
Yeah. Could you imagine slipping and sliding on sandpaper?
No.
Would you move very far across it? No, if your feet hit sandpaper, it's going to have a hard time moving. But if they hit ice, shoosh, you're out of there, right? So sandpaper has a lot more friction or a lot less friction? A lot more friction. Good. This water slide is smooth, so it has very little friction. So increasing friction. Sometimes it is helpful to increase friction. People use rough or sticky materials to increase friction. The brakes on a bike use rubber pads to increase friction. When you squeeze the brake handles, the brake pads press against the rim of the wheel, and the friction between the pad and the rim cause the brake to stop. So that rubber is what's helping have more friction. If you didn't have it on there, it would be a lot harder. Reducing frictions. At other times, it is useful to reduce friction. People use slippery things to reduce friction. Oil is often put on moving parts of machines to reduce friction between them. So what might help reduce friction? Oil. Good. Without oil, friction between the moving parts of the engine will cause the parts to wear out. If you have been to a hockey game, you might have seen an ice resurfacer used to polish the ice. This machine puts down a thin layer of water to make the ice smoother. This layer of water reduces the friction that helps the players skate faster. This machine cleans and smooths ice surfaces, reducing friction. And up here we see the brake pad, the wheel rim, and then friction between the brake pad and the bike rim stops the bike. So we have contact forces. Friction is going to be that rubbing. Are there times we want to increase friction? Like on bikes, right? Bike brakes. Are there times we want to reduce friction?
Yes.
Yeah, like on the ice or machine parts, right? Good. We are going to stop there with this today, and we'll come back and revisit more of it tomorrow. Sound good? Perfect. Go ahead and clean up and get your stuff put away.